Bismillahirrahmanirrahim. An operation consists of two redundant parts. The first part has two components in series, W1 and W2, and the second part has two components in series, W3 and W4. All the components succeed with probability P is equal to 0.9. Draw a diagram of the operation and calculate the probability that the operation succeeds. So the component has two parts, right? Redundant part. So redundant part means these are in parallel, right? And the first part has two components in series, and the second part also has two components in series, right? So the diagram, the first part, it has two parts in series, W1 and W2, right? W1 and W2. The second part, it also has two components in series. These are W3 and W4. So these are redundant parts. So redundant parts means these are in parallel like this. So this gives us the diagram of the operation. So all components succeed with probability P is equal to 0.9. P is equal to 0.9 for each component. So we have already drawn the diagram, and we need to calculate the probability that the operation succeeds. So there are two parts. For each part we can calculate a probability. For example, these components in series can be thought of as part A, and this can be thought of as part A. So part A, B, that operation will be represented by WA is equal to W1 intersection W2, right? And the part B, WB is equal to W3 intersection W4. So the probability of part A, WA, the probability PWA is equal to the probability of W1, W2, that is P multiplied by P. P multiplied by P, that is 0.9 multiplied by 0.9, that is 0.81. Similarly, the probability of the second part is also the same, probability of W3, W4, and that again is 0.9, 0.9 is equal to 0.81. So the probability of success of each of the two redundant parts is the same, that is 0.81. So let this be represented by PWA is equal to PWB, let this be PAB, and this is 0.81. Now these two parts in parallel, so the operation W is equal to WA and union WB. So the probability of success of W is equal to 1 minus P AB and raised to the power the number of times the redundancy is there. So this is 2 here. So this is 1 minus 0.81 and raised to the power 2. So this is probability of success of this whole part is 1 minus now 0.1 minus 0.81 is 0.19 raised to the power 2, right? So 1 minus 0.81 is 0.19, right? And that squared is 0.1 minus 0.0361. So the probability of success of the whole operation is 1 minus this is equal to 0.9639. So this gives us the probability of success of the whole operation. So it should be noted that if we do not use a redundant part, if we rely on only one part, for example, the probability of success is 0.81 only. However, if we add only one redundant part, then the probability of success rises to 0.9639, which is quite a large value compared to 0.81.